Hi, in this video I'll be talking about functions in Python, focusing on closure and lexical scope. I'll start with lexical scope. Lexical scope is a method used by Python to determine the values of variables and where variables can be found. I'll explain. Let's say x here is its value is not found within the local scope here, so Python has to find it somewhere else. So the first thing it does is obviously we check the local. It's not there, so the first thing it does is look one level up, which is the enclosing scope, in this case function a. So we go and knock and check whether x is there or not. So if x is defined here within the enclosing scope, then that's fine. Now we know what the value of x is, right? But in circumstances where x is not found within the enclosing scope, then Python jumps to the global scope and checks whether x is there. If it's there, the same thing happens. Then we know the value of x, it's found in the global scope, that's fine. If it's not found there, then we will go and check within the built-in scope. If it's not found there, then there is an exception called name error exception. Okay, that's it. That's lexical scope. There's nothing to it. Well, there is something to it. I lied. Two things. First is there's something called variable shadowing. I have now within the enclosing scope, I have x defined as 7. But if I'm to update x here and say x is 5, now my function b will know x to be 5 from now on because it will default to the local scope. And now this is called shadowing. I'm shadowing the x that's defined in function a. But if I'm purposefully interested in updating the x that's defined in function a, what I would do is I will define x as non-local, like so, with n small n here. And Python would know that I am updating the original x that is defined within function a and not the x within function b, okay? But if also I'm interested in updating an x or a y that's defined within the global scope, then I can use the keyword global with small g x and update that x. Then Python would know that what I meant is to update the global x and not create a shadow within the local scope. Now that's it. I meant it this time. So this is lexical scope. Now that we have an understanding of what scoping is, let's talk about closure, right? So as we discussed earlier, now x is not defined within function b. Rather, it's a reference to the definition of x, which resides within function a. So when we call function a, and we're now assuming function a is returning function b, right? At that point, function a is called, completed, and garbage collected. However, function b still remembers the value of x to be 7. That scenario of function b remembering the value 7, even though the enclosing function is done and dusted, is called closure. How does Python achieve this? We'll look into it in depth using Jupyter Notebook because it's much better to see it that way. And we get to introspect the closure and see exactly how values are stored within closure. Okay, right. Here we have the exact same scenario. An enclosing function, we call it outer func, and a nested function called inner func. So the nested function is referring to value x or x variable from the outer function, okay? And then the outer function is returning the inner function. So now let's go ahead and see how closure works in this case, right? So let's define outer func. We pass in number 2. Now outer returns inner func. Inner func is expecting one more value, so let's supply that value. Let's say 3 and see the value. Right, we got 11. How does this work? If you see line number 2, right here, outer func has returned inner func and it's done. It's garbage collected. However, value of x is not garbage collected because we're still keeping, the inner function is still keeping a reference to x. So Python's garbage collector will ignore it, will keep it. Not only that, but some other thing also happens in this case, right? Python functions come with an attribute called closure. So let's go and inspect closure here. See, in our case, the closure of inner func is now populated, okay, with an integer object. So you can guess what that object is, right? It's 2 because we passed in 2, the value of x is 2, and we can, go a little deeper and, make sure that it's actually 2, but it is. So it's a tuple that contains a cell object. This is the memory reference, and it contains, that cell object contains an integer value. So our functions closure object now contains a cell, a tuple that contains a cell. So let's go ahead and access that cell, right? So we know that we only have one value in our tuple, so index 0. Now we get the cell, and the cell object has an attribute called cell contents. And what did I tell you? 2. So now we know for fact that our inner function is keeping 2, which is x value, in its closure object under a tuple under cell. Okay, that is how closure is stored within a function. Now, how can we make sure that it's actually a value that's bound to x? We can check using code co-free_var, co-free_vars. There you go. So we take outer, which is bound to inner func, check the code object, and then within code object we check free_var. The reason why x is called a free_var is because x is not defined within inner func scope, so it's referred as free_var. And this is how closure works. I hope it's clear. Thanks for watching.